This is Algebra Lesson 7-4, Applications of Linear Systems, which basically means word problems. Before you can solve any word problem, you have to determine several things. There are some really good questions to ask yourself after you've read over a word problem 1 or 2 times. One question you should ask, what do I know? Second question, what am I trying to find, or what do I need to know? And third question, how can I use what I know to find what I need to find? There are 3 methods for solving systems of linear equations. And it does not matter which method you choose to use. You may choose any method at any time. Just choose whichever one you're more familiar with, more comfortable with, or whichever one seems to fit the situation the best. Graphing is really good for solving systems that are easily graphed or are very visual. Substitution is very good for systems where you have one variable that doesn't have a coefficient larger than 1 or -1. Like you have 4x plus y equals 6, and you can solve it for y very simply. And elimination is really good for just about any system. Some people work with elimination quite well, others don't, so they prefer substitution. Let's take a look at a question here. A metal worker has some ingots of metal alloy that are 25% copper and others that are 50% copper. How many kilograms of each type of ingot should a metal worker combine to create 40 kilograms of a 45% alloy? This is what I know. I have some copper at 25% and some at 50%. I know I need to get it at 45%. Do I know how much copper at 25% and how much copper at 50%? No, that's what I'm asked to solve for. So my first thing is I'm going to start with using some variables. I'm just going to let x equal the amount that I need at 25%. I will let y equal the amount that I need at 50%. Now, if I'm trying to get 45%, my brain automatically says I'm going to need more at 50% and less at 25%. So when I get to my final answer, my number for 50% better be higher than my number for 25%. That's one of the things I'm going to keep in the back of my mind. Now, I know I need some alloys at 25% and 50% and making up a combination at 45%. I also know I need a total of 40 kilograms. So I can get 2 equations by using those 2 things. I'm going to do one equation based on the mass of my alloys. And I'm going to do one equation based on the percentage of my alloys. So, mass of alloy. I do not know how much I have at 25%, nor do I know how much I have at 50%. But I know I need 40 kilograms. So the amount at 25% plus the amount at 50% has to equal 40. Since I don't know what that amount is, so x plus y equals 40. For my percentage, remember, a percentage is going to be the decimal times the amount. So the decimal for 25% is 0.25, so 0.25 times the amount of alloy, which I don't know, so I'll call that x, plus the percentage of 50% is 0.50y. That has to equal, I need 45%, but I need 40 kilograms at 45%, so I'm going to multiply 45 times 40. To simplify this second equation, if I multiply that out, 0.25x plus 0.50y equals 4.45 times 40 is 18. So I have 2 equations. This equation here, x plus y equals 40. My second equation, 0.25x plus 0.50y equals 18. I could use elimination. I could use substitution. It really doesn't matter. I think elimination might be a little faster in this one. So I'm going to take this first equation and I'm going to multiply it by negative 0.25. So if I do that, I'm going to have negative 0.25x minus 0.25y. 40 times 0.25, or 1/4 of 40, is negative 10. Don't lose your negative sign. Keep my second equation just as I see it. 0.25x plus 0.50y equals 18. So in solving this, the x's cancel. Negative 0.25 plus 0.5 is 0.25y. And negative 10 plus 18 is 8. Divide by 0.25. Y equals 8 divided by 0.25, which happens to be 32. Which seems reasonable. It's less than 40. So I know I'm at least reasonable here, and I know I need a lot more of 45% or the 50% alloy than I do the 25% alloy because I have to get to 45%. So if y equals 32, x plus y equals 40. So if we take x plus 32 equals 40, x has to equal 8. So I will need 8 kilograms at 25% and 32 kilograms at 50%. Always writing your answer in a complete sentence. And that makes reasonable sense because I already said at the beginning of the problem that I knew I was going to have more of the 50% alloy because I have to get it to 45%. All right, question number 2. Let's say you have a typing service. You want to make some money. You buy a laptop for $1,750. Very, very nice. Top of the line laptop with all the bells and whistles, all the programs you'll ever need. On which to do your typing. You charge $5.50 per page for typing. Expenses are 50 cents per page for ink, paper, electricity, and anything else that might incur. How many pages must you type to break even? This is a break-even type of problem. In order to break even, your expenses, what you spend, must equal your income, what you bring in. So in other words, what it costs you in electricity, ink, and paper has got to be equal to what you're bringing in, how much money people are paying you to type papers. That's what you need to know. Whenever you have an equation about breaking even, okay, whenever you have a problem that asks you to break even, one of the things is going to be based upon your expenses, and one of the things is going to be based upon your income. Okay. So the easiest way to do this is I'm going to look at this in 2 ways. Okay. I need pages. Okay. I get so much money per page that I type. Okay. So one equation is based upon my expenses and my income. Okay. So my expenses or my income equation. There's always an equation based upon expenses or income. That's going to be equal to my y. Okay, or x, it doesn't really matter. Oops. I'm going to make it equal to y. And I'm going to let the number of pages equal my x. So the number of pages I type is going to equal x, and my income or my expense is going to equal y. Okay. So I need one equation based upon expenses and one equation based upon income. That's why it says expenses / income here. I'm going to have 2 equations. One's based on my income and one's based on my expenses. So my expenses equation. How much did I have? What do I have to pay out? Well, I had to buy a laptop. That cost me quite a bit of money, $1,750. So my expenses are equal to the cost of my laptop, $1,750, plus 50 cents per page, so 0.50 times x. There's one equation. And you could rewrite that as y equals 0.50x plus 1750. Doesn't matter. My income equation, y equals how much money do I make? I make $5.50 per page for typing. Oops, my decimal point in the wrong place. So I have 2 equations, one based on expenses and one based upon income. And as my first thing says, my expenses have to equal my income in order for me to break even. So simply put, I'm going to set those 2 equations equal to each other. So expenses equals income, which is kind of nice because if you look at it, I can substitute in. I can substitute in for either one. So since my expenses equals my income, I'm going to put in 5.50x for y over here. So I have 5.50x equals 1750 plus 0.50x. Now to solve for x, I'm going to subtract 50 cents over here, subtract 50 cents over here, I now have 5x equals 1750. Divide by 5. 1750 divided by 5 is equal to 350. So until I type 350 pages, I will not make any money. I will lose money because of the cost of the laptop. So how many pages must I type to break even? Must type 350 pages to break even. That's a lot of pages. Which is why a lot of businesses, the first couple of years, don't make a lot of money because they have to recuperate all the expenses that they had to put out to begin their business. Right, remember the distance, rate, time problems we had before? Well, they show up again, but now we're going to use two variables to solve these distance, rate, time problems. I actually find them to be a little bit easier with two variables than they are with one variable. But it's all up to you. You do need to use two variables for these. Okay. So here we have two cars leave town at the same time in opposite directions. One travels at 35 kilometers per hour and the other at 40 kilometers per hour. And how many hours will they be 200 kilometers apart? Okay, let's make our little distance rate timetable. Okay, distance, rate, time. I have two cars. For lack of a better thing, car number one, car number two. Okay. And how many hours will they be 200 kilometers apart? So in other words, I'm looking for time. Okay, so I'm going to let t equal time in hours. And I do know that they're traveling in opposite directions. So one's going that way and one's going that way. Okay. So the distance that they travel is equal to their rate times their time. One car travels 35 and one car travels 40. We do not know how long either one of them travels, but we know they each have to travel a specific distance. So distance equals rate times time. Okay, so in this first equation we have d equals 35t. In the second equation we have d equals 40t. Two equations, equation 1 and equation 2. I can use substitution really easily because I already have one's variable solved. It says d equals 35t. So now in equation 2, every time I see a d, I'm going to put in 35t. So I now have 35t equals 40t. Okay? You're going to be going, but that doesn't make much sense. How can 35t equal 40t? Well, really it doesn't. Okay? But we have to get into this thing that they are 200 kilometers apart, don't we? And we have to take that into consideration. The distance of the first car plus the distance of the second car has to equal a total of 200 miles, doesn't it? Okay, so let's go back, because substitution is not going to work really well here, is it? So let's go back here and let's look at this. Distance of car 1, distance car 1, plus distance car 2, has to equal total distance, 200 kilometers. So what's the distance of car 1? 35t. What's the distance of car 2? 40t. And that has to equal 200. 35t plus 40t is 75t. And that has to equal 200. Divide by 75. If you take 200 and divide it by 75, you are going to get 2.6 repeating, which you know me, don't like decimals, especially if they don't terminate. 0.6 repeating is 2/3, in case you couldn't remember. So t will equal 2 2/3 hours, or for those of you who like hours and minutes, 2 hours and 40 minutes. Okay. So it will take 2 2/3 hours, or 2 hours and 40 minutes. That's one distance rate time problem. All right, here's another one. Distance rate time problems can be modeled using two variables. We talked about this. This is really, really, really helpful when you're dealing with water currents, air currents, wind, things that can make you slower or faster. Remember, the steady west to east winds across the United States act as a tailwind for planes that travel from the west coast to the east coast, and it acts as a headwind the other direction. Okay? A tailwind will increase the plane's speed, therefore it should get to its destination faster. And of course, a headwind will decrease the plane's speed. So let's take a look at this first question here. A plane takes about 6 hours to fly 2,400 miles from New York City to Seattle, Washington. At the same time, your friend flies from Seattle to New York. His plane travels with the same average airspeed, but his flight takes 5 hours. Find the average airspeed of the planes, find the average wind speed. Okay, so we have two things. The easiest way to do this, New York to Seattle, Seattle to New York. Distance, rate, time. All right. A plane takes about 6 hours to fly from New York City to Seattle, Washington. So 6 hours, 2,400 miles. Okay, your friend who flies from Seattle to New York, his plane travels with the same average airspeed, but his flight takes 5 hours to travel 2,400 miles. You might say, well, what do we put in for the rate? Well, here's the deal. This guy's got a headwind. He has a tailwind. A headwind hurts you, a tailwind helps you. Okay, so we have two speeds. We have the speed of the plane and we have the speed of the wind. Let's let R equal the plane's rate. Let W equal the wind's rate. And remember, if the wind is stronger than the plane will never get off the ground. So if you get an answer where, oh, the plane's traveling 100 miles an hour, but the wind's traveling 400 miles an hour, you did something wrong because you can't possibly have a wind stronger than an airplane and an airplane be flying. Not going to happen. So if it's a headwind, it's going to be the rate of the plane minus the rate of the wind because the wind is not helping it, it's hurting it, it's pushing it backwards, so it's slowing it down. So we have to subtract that wind speed from the rate of the plane. If it's a tailwind, it's pushing it along. It's kind of like running against the wind and running with the wind. If you've ever had to run against the wind, you have to take a lot more energy to stay at the same pace. So this will be R plus W. We know that distance equals rate times time. We've known that all along. So since distance equals rate times time, my first equation, 2,400, equals my rate, R minus W, times my time, 6. My second equation, 2,400, will equal my rate, R plus W, times 5. Now, interestingly enough, there's some really, really quick tricks that you can do to make this really easy. The first thing I'm going to do is I'm going to see if 2,400 is divisible by 6, which I know it is because I know 24 is divisible by 6. I know 2,400 is also divisible by 5 because it ends in a 0. So I'm going to take this first equation here and I'm going to divide it by 6. I'm going to take my second equation and divide it by 5. Why do I do that? Smaller numbers. I could distribute the 6 through and then do all this other stuff and find a common denominator and all that other stuff, but it will be harder. I'm just going to make it easy. So if I take 2,400 and I divide it by 6, I'm going to get 400 equals, if I divide this side by 6, I just get R minus W. If I take 2,400 and I divide it by 5, I'm going to get 480. And if I take R plus W times 5 and divide that by 5, I'm just going to get R plus W. Now look at this. I have two equations, two unknowns, and if I add them together right now, the wind speeds cancel out. So here I have my two equations. The W's cancel out. So I have 880 equals 2R. R plus R is 2R. Divide by 2. R equals 440. So the rate of my plane, The ground speed of my plane is 440 miles per hour. Now to find my wind speed, I can substitute that into either one of these equations, this one, or the equivalent ones over here. I'm going to substitute it into equation 2. I have 480 equals 440 plus W. So I will subtract 440. And I get 40 equals W. So the question asked me to find the average wind speed. This is the plane's speed, and this is the wind's speed. So if it says, find the average airspeed of the plane, find the average wind speed, okay? The planes are traveling at 440 miles per hour, and the wind is 40 miles per hour, which makes sense because if the wind was stronger than the plane, they'd never get off the ground. We talked about that. All right, last question. Suppose it takes you and a friend 3.2 hours to commute 12 miles downstream. During the return trip, it takes you and your friend 4.8 hours to paddle upstream to the original starting point. Find the average paddling speed of you and your friend and the average speed of the current of the river. And round your answers to the nearest 10. Okay, so we're going downstream, we're going upstream. Okay, so the first one talks about downstream, so we'll talk about down first, and then we'll talk about up. Distance, rate, time. And you don't ever round your answers to the nearest 10. Ignore that. Right? So, suppose it takes you and a friend 3.2 hours, so we'll put 3.2 in here, to canoe 12 miles downstream. During the return trip, it takes you and your friend 4.8 hours to paddle upstream to the original starting point, which means the distance is the same. Okay, we need the average paddling speed, and we need the average speed of the current. So let R equal paddling speed. And I'm going to let C equal speed of current. If you've ever traveled in a river, you know that the current can be quite swift at times. So if you're going downstream, the current is helping you. It's pushing you down the stream. So that's going to be your rate plus the rate of the current. It has to be your rate first. If you are not traveling faster than the current, you're never going to go anywhere. So your speed has to come first. For coming upstream, it's your speed minus the current because the current's pushing against you, so it's slowing you down. So we have two equations again, distance equals rate times time. So 12 is going to equal 3.2 times R plus C. And here, 12 is going to equal 4.8 times R minus C. Again, I'm going to see if I can divide everything by 3.2 and 4.8, because that might be much more helpful. And when I do that, 12 divided by 3.2 is 3.75. And that will equal R plus C. And 12 divided by 4.8 is 2.5. And that will equal R minus C. So I have two equations here. If I added them together, 3.75 plus 2.5 is 6.25. The C's will cancel, and I get 2R. If I take 6.25 and I divide it by 2, R will equal 3.125. So the rate of me and my friend paddling is 3.125 miles per hour. I think it's kilometers. Miles. Now to find the rate of the current, I'll use the second equation here, where it says 2.5 equals 3.125 minus C. So I'll subtract 3.125. I take 2.5 and I subtract 3.125, I get negative 0.625 equals negative c, which is good because a negative equals negative. I can divide by a negative and I get 0.625 equals c. So here I have paddle speed is 3.125 miles per hour, and speed of the current is 0.625 miles per hour. These word problems are not difficult because they set up very similarly to the ones that only had one variable. You now just have to use two variables instead, which I find slightly easier to solve.